Welcome back, pre-calculus students. Today we are going to look at how to solve systems with matrices, and then we're going to do a type of application. Before we get started, I wanted to offer you up a homework quiz. Typically, when we're not learning online, we have a homework quiz at this point. And just to review it, you can stop the video at any point and review, but you've got adding and subtract, or scalar multiplication with subtraction. You've got multiplying two matrices. You've got finding a determinant. And remember, the little absolute value bars mean determinant. And then finding the inverse. Now, this is a calculator quiz, so you can use your calculator for the whole thing to practice. I'm going to go ahead and show you the answers, but at some point you can stop and work these. So here's the answer key. And here are the answers down here and here. Now, let's look at our topics for today. The first topic we're going to look at is just solving two variable system by hand. And you might remember this from Algebra 1 and Algebra 2. So what you want to do, I always try to just eliminate. So you're trying to get variables or coefficients on the variables the same number, opposite signs. So you would want a -3 and a +3. Well, that's not going to work out well unless we multiply by 2 and 3. And then over here we have a +4 and a -1. So this one's the easiest to multiply through by. So let's multiply this by 4. That will give us a +4y and a -4y. So I'm going to distribute the 4 in and get 8x minus 4y is equal to -40. And then I'm just going to eliminate this because I've just multiplied it. Now let's add our two equations together. When we add, the y's cancel, and I end up with 5x, -3 plus 8, and I get -35 for my constants when I add those. And so x is -7. And then once we get one variable, the second variable is easy. We pick an equation and plug in -7. So let's plug in -7 into the first equation. And that would be -3 times -7 plus 4y is equal to 5. So that's going to give us a +21. And we're going to have to subtract it from both sides. And so that's going to give us, what's that, 16 over here? Y, 4y is equal to a -16. So y is -4. So our answer, remember, is an ordered pair. It's a point where these two lines intersect at -7, -4. So that's how we solve a system by hand. Let's look at one more. Okay, so we have x plus y is 2, and 7x plus 8y is 21. Okay, we want to have something cancel out, so I'm going to multiply this time by -7 so I can make my x values cancel. So that's going to give me -7x minus 7y minus 4 is equal to -14. And then when I add, my x's cancel, my y's, I get +y is equal to 7. And then plug that value in. Up here, the first one, x plus 7 is equal to 2. So x must be -5. And again, I'm going to write my answer as an ordered pair solution. So be careful because the second one we found was actually x. That's -5. And then +7. And then you can plug it into the second equation and make sure it works. So that'd be -35 plus what's that, 56, and that's going to give us 21. So now we're going to go to a next topic, which is solving those same systems of equations, but this time we're going to solve using matrices. So in your interactive notebook, this is page 13. You want to write down what's on the screen right now, solving systems with matrices. So step 1, you're going to write this system of equations as a matrix equation. So basically, we're kind of translating it, kind of like you would do when you translate from French to English or Spanish to English. We're going to translate it to a matrix equation. And this is what the equation is going to look like. You're going to have a coefficient matrix, and this coefficient matrix needs to be a square matrix. So if you have two variables, you have two equations. If you have three variables, you have three equations. So the coefficients are always a square. You're going to multiply it times a variable matrix. This is always going to be a column of variables. So it's going to go up and down. And you're going to set it equal to the solutions or the constant matrix. And that is also another column. Okay, then we're going to learn to solve it. So let's walk through these and look at how we're going to solve these. We're going to solve them using matrices. So the first one is a 2 by 2. And we're going to first just set up the equation. And the equation's going to look like this. The coefficients, there are 4 of them, are going to go in a 2 by 2 matrix. So the first row is -3 and +4. And again, if these variables are in the wrong order, you need to get them in the right order. So the x's are the first column and the y's are the second column. These are already set up for us. And then the second row is 2 and, of course, -1. So that's how we set up our coefficients. Now our variables, this is going to be a column. And the column is whatever's first, x, and whatever variable is second, y. Now, let's stop for a second so you can look why that works. Because when we multiply matrices, don't we do rows times columns? So you would have -3 plus 4y, and that's where that equation comes from. Okay, just to show you. And that equals our solutions or our constants. And the constants are just another column. And that's going to be 5 and -10. Now, what we're going to do from here is multiply the inverse matrix times both sides. So what we can do is find the inverse of this matrix. So we can find the inverse of a 2 by 2 pretty quickly. Remember, we flip-flop A and D, and we change the signs of B and C. So we can move the -1 to here, the -3 to here, change the sign to -4 and -2. Now, we don't ever want to forget to multiply through by 1 over the determinant. So let's calculate the determinant. This is going to be 3 minus 8, so that's -5. So -5 is the determinant of the original 2 by 2 matrix, so we do 1 over -5, and then we distribute that in, and we get some fractions. Now, once we get that inverse matrix, which is now, once I distribute, it's going to be +1/5, +4/5, 2/5, and 3/5. Well, at least everything ended up being positive. That makes it a little bit easier. We're going to take that inverse and we're going to multiply it times the solutions, which in this case is 5, -10. I believe that's right. Let's double check. There we go. So you can take this row times the column. When you do that, you're going to get the answer for x and y. So what are we doing? We're finding, we have 3 matrices. We have matrix A, a variable matrix, and matrix B, the constant matrix. We're finding the inverse of A, which is this one, and we're multiplying it times the other matrix B. And that's going to give us our solutions. The inverse of A times the constant matrix, or the solutions, B, and that gives us our variables. So now we can multiply 1/5 times 5. Let's multiply that. 1/5 times 5 is just 1. 4/5 times -10 is what's that? Negative 40 divided by 5, so that's negative 8. So plus negative 8. So that's going to give us in the top, I'll write this out, in the top position, negative 7. That means that's what x is. And then we can do the same thing here. Second row, first column, 2/5 times 5, 2. 3/5 times negative 10, that's negative 30 over 5, which is negative 6. We're going to subtract, remember, we're going to add those together. 2 plus negative 6, so negative 4. And there we go. So 10, make sure that looks right, 30, negative 6, yeah. And there are the answers, okay? I hope I did that right. A inverse B, rows, columns, added them up. Okay, so that's how we find it. Now, let's go back and look at the 3 by 3. Okay, here's our 3 by 3 matrix, and we surely don't want to do that with without a calculator. So let's just set it up. Okay, set up the coefficient matrix, a variable matrix, and that's going to be equal to a constant matrix, or as I call it, the solutions. So our variable matrix, because we're in order x, y, z, x, y, z, x, y, z, I don't have to move anything around. So I'm just going to write my first row as 1, 1, 1, 7, 8, negative 1, negative 2, negative 1, positive 3. So there's the coefficient matrix. The variables, what order are these in? X, Y, and Z. And then our constant matrix, which is 3, and 20, and 0. Now, to solve this, I'm going to take this and put it in my calculator as A. And I'm going to put in my solutions as B, and then I'm going to do the commands A inverse times B. And that should give me a 3 rows, 1 column solution for X, Y, and Z. So now let's grab our calculators. Calculator. Okay, so the first thing I'm going to do is second matrix. I'm going to go over and edit a 3 by 3 matrix because that's going to be A, my coefficients. So 3 by 3, which was already set up. Oops, I did a 1 by 3. Let's go back. Oh, I created a third one. I didn't want to do that. Okay, 3 by 3. And I'm going to go 1, first row 1, 1. Go ahead and do this with me. 7. You guys are probably faster than me anyway. Negative 1. And negative 2. Negative 1. And positive 3. So once you get it in there, remember to quit. Second and mode quits and goes back to the home screen. Now, we want to put matrix B in, or this solutions matrix. So let's go to second matrix. This time we're going to go over to B, and we're going to edit B. But B is now 3 by 1. So 3 by 1, it's very easy. It's just 3 and 20 and 0. And let's quit. So second mode quits and goes back to the home screen. And I can clear it from here if I want to too. Just get rid of all that work. Now, to type it in the calculator to solve this system, we're going to take A, and to get the name A, we do second matrix, stay on this screen, and just choose A, which is number 1. We're on it. We want to find the inverse, so we're going to raise it to the negative first. You guys did that for homework last night. Times, and then B. We just need the name B, so second matrix. I did the wrong one. Second matrix, you go down to the 3 by 1 and enter. So hit enter one more time to get the solution, and there's the solution. So not real pretty. Let's change those to fractions. So let's see, let's just hit our math button, and boom, there are the answers. So the answers are x is, whoops, let me get my screen back up here. I'll just snip it, how's that? So you guys can see it a little bit better. Negative 11/13 and 43/13 and 7/13. So those variables are in the order of x, y, and z, because that's my solution. Okay, and that's how you handle these. So let's look at one more application. How do you find the area of a triangle with matrices? Well, this works if you have a graph or if you are using a Cartesian coordinate plane. This will be page 14 in your interactive notebook, so you can stop and write this equation down. The area of a triangle, the area of a triangle with the vertices x1, y1, x2, y2, and x3, y3 is given by area equals positive or negative, and that depends on if your determinant ends up being negative, you change it to a positive. If it's positive, you keep it a positive. So 1/2 the determinant of this matrix, which you just put the variables in, x, y1, x2, y21, and x3, y31. Just set up this little 3x3 matrix, find the determinant, because that's what those bars mean, and then make it positive, which is why we have a plus or minus, and then take half, because we know just like the area of a triangle is 1/2 base times height. Okay, so let's try one. Here's our triangle. It's on the Cartesian coordinate plane. So we're going to do 1/2 the determinant of 1, 7, 1, 5, 8, 1, 7, -4, 1. So that final column is always ones. And you take half of this determinant, and then you just make it positive if it's negative. Okay, so let's grab our calculators. I'm going to go ahead and put in 0.5 times, whoops, we're not quite ready for that part, are we? Let's put in our matrix. So second matrix, go over, I'm just going to use A again because A is already set up to be a 3x3. So 3x3, boom, boom. Okay, so what's that? 1, 7, and 1. 5, 8, and 1, and 7, and -4, and 1. So always double check, make sure your matrix looks good. Then we're going to quit second and quit, go back to the home screen. Now we're going to take 0.5 or 1/2 times the determinant. Now, do you remember where the determinant button is? Second matrix, go over to math, choose the first choice, determinant, and of course we were in A, so second matrix. We just want to pull up the name and enter. So it's -25, but we know area can't be negative, so we know the area must be 25 square units, and that's our area. Okay, here's one more example. This one, we don't even have a picture, but we set it up the exact same way. Now, does the order matter? And the answer is no. The order does not matter. I can do this one, then this one, then this one, or I could start with a 0.10, -5. It doesn't matter. Okay, 10, -5, 1, and 3, 0, 1. Find that determinant, take 1/2 of it. So let's go back one more time, walk in the steps, second matrix, go over to edit, choose matrix, Doesn't matter which one. I'm still choosing A because it's already set up. -2 and 9 and 1. 10 and 5, -5 and 1 and 3 and 0 and 1. And then quit to go back to my home screen. And then from the home screen, I want 1/2 of it, or 0.5 times the determinant, second matrix, math, determinant of which one? I put it in A. Boom. This one's -19, and what do we know? It's got to be positive 19 square units. So this is actually a negative here, and this one's actually a negative here to make it true, to make them positives. So there you go. And that's how you find area of a triangle given 3 vertices. Okay, so what do we need to know at the end of this lesson? 1, calculator skills, that little practice quiz we did at the beginning. Then, how do you solve a 2-variable system by hand? Elimination. You could use substitution if you want, but those were set up for elimination. What did we learn new today? We solved a 2 or a 3-variable system using matrices, where we put the coefficients in and do A inverse times B. And that gives us our solutions. And then, how do we find the area of a triangle using matrices? We use 1/2 of the determinant, right? And then we always make it positive. And so what are we doing after this? We are going to do worksheet 4, which goes along with page 13 and 14 in the interactive notebook. I hope this video has been helpful.